Find the power absorbed by the 6 kilo ohm resistor in the network in this figure here. Okay, so we are asked to find the power absorbed by the 6 kilo ohm resistor, which is this one here. But then what is power? Power is voltage multiplied by the current, right? Let's take a note here. So power is the voltage multiplied by the current. So we need two things here. We need the voltage and then we need the current. Let's say if the current that passed through this 6 kilo ohm resistor is here, and then the voltage is here. So we need to multiply the voltage here with this current here. And we will use nodal analysis. So I will use nodal analysis or using Kirchhoff's current law, right? Nodal analysis or KCL. But then we need to first label all the nodes first. Label all the nodes. Okay, let's see what can we get from the circuit here. So let's use this bottommost node here as our reference node or our ground. So we'll have this as our reference node or our ground, in which the voltage here will be 0, right? So V is equal to 0. And here we have another node here, a very long node here, but it is only one node. And let's name this node here as VA, right? Because let's name this node as node A, and the voltage here will be VA. Good. And we already label all the nodes. Let's move on to the second step, which is to assume the current's direction. Assume the current's direction. How to do that? We can just assume on this one here. Usually for the vertical component, I just goes to the ground. So I assume it goes down. It also goes down. And here I also assume it goes down. But you can also assume it going up. It will be the same result. But for the branch with the current source, I just follow the arrow of the current source. So let's go down there and let's go up there. Good. And now what can we do next? We can do KCL at node VA here, non-reference node. So we will need to do KCL at non-reference node. And the only non-reference node here is VA here. Good. So let's do exactly that. KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And let's see here. The only current that goes into VA comes from this one here, which is 4 milliampere. We can just write 4 milliampere there. And then let's do all the currents that goes out. Let's see here. The first one is this one, but we know exactly that current is, which is 6 milliampere. So we will have 6 here. Good. And then what else can we do? We have another 3 currents here. So we'll have this current, and this current here. But we have resistor here, and we don't know the current yet. But we can use the equation for Ohm's law in this resistor here. So in this 4 kilo ohm here, the current comes from this node here, VA. So I will write VA first. So the current comes from VA, and then the current goes to the ground. The ground, I will have the voltage there is 0. But remember, this is a voltage. To get current, we need to divide it by the resistance, which is 4 kilo ohm. Good. And now let's play the same game for this 6 kilo ohm resistor. So we will have VA. VA is where the current comes from, and then it goes to V0 here, the ground. So I will have minus 0. Good. And then this is voltage. To get current, we divide by the resistance between them, which is 6 again we played the same game, and the last one is here. So we'll have plus VA minus 0, and then divided by the resistance between them, which is 12. Good. Now we can multiply both sides by 12 to cancel out all the denominator here, right? 4, 6, and 12 all will cancel into 12, right? So 4 multiplied by 12, that will be 48. And then that will equal to 6 multiplied by 12, that will be 72. And then plus 4 and 12 will cancel into 3, so I will have 3 VA. And then 6 and 12 will cancel into 2, so I will have plus 2 VA. And then 12 and 12 will cancel out into 1, so I will have plus VA. Good. And now what can we get from here? So let's move this 72 to the left hand side. So I will have 48 minus 72. And then on the right hand side, we will have 3 plus 2 plus 1. That will be 6 VA. Good. And I think I can isolate VA here. I don't divide this because I think it will be easier this way. So I'll have 48 minus 72 divided by 6. So we'll have 48 divided by 6 is 8, right? And then 72 divided by 6, that will be 12. So I will have VA here is equal to minus 4. And the unit here will be in volt. Good. And now, let's see what can we do from here. We know that VA is minus 4 volt. This is a very important value here. Why? Because the voltage across this 6 kilo ohm is VA minus 0, right? So the voltage here is VA minus 0. But then the current there is VA minus 0 divided by 6. So I have VA minus 0 divided by 6. Good. So we will have VA squared and then divided by 6. And we can just plug this minus 4 here. So I'll have P is equal to minus 4 squared divided by 6. And what is it? And I think I just use calculator for that. 4 squared is 16 and then divided by 6. So we will have 2.67. 2.67. And I think the unit will be in watt here. Oh no, the unit will be not in watt but in milliwatt. Why? Because the current is in milliampere and the voltage is in volt, right? So I will have milliwatt here. So the power here is 2.67 milliwatt. And I think that's all for this problem. Hopefully I did not make any mistakes in my calculation. This is the final answer. The power absorbed by the 6 kilo ohm resistor is 2.67 milliwatt. Okay, thank you for watching. See you in the next video. Bye bye.